Welcome to Season 4 of Maker Club by EE Focus in partnership with the Hackaday Innovators, a world-renowned hardware innovation contest, and DigiKey, a global leader of distribution of electronic components and automation products worldwide. As our long-term partner, DigiKey will continue to support makers embarking on a journey of innovation, exploring the possibilities of technology, and creating a better new world together. They co-founded MoonMakers, a Mexican nonprofit. They promote creativity via maker culture and STEM education. They've partnered with organizations like Sesame Street and Arduino to expand access to creative technologies for young learners. What is the story behind the name MoonMakers? What is its mission and vision?
Hi, my name is Diego.
And I'm Camila, and we're the siblings behind MoonMakers.
MoonMakers is an educational non-profit with a hands-on learning experience that combines science, technology, engineering, art, and math, helping students for all ages explore topics like artificial intelligence, programming, and digital fabrication through the project's based learning and design thinking.
We're passionate about making education feel exciting, playful, and empowering, especially in communities where access to tech is still limited.
We also work closely with educators, creating tools and resources that help bring this experience into classrooms, especially in places where the access to tech education is limited.
Over the years, we had the chance to collaborate with incredible organizations like Sesame Street, Make Community, Science Writing, Arduino, Raspberry Pi, Microbit Educational Foundation, and in Mexico with CONACYT, the Secretary of Education, among other foundations and institutions. And now, the name.
As for the name, it's part personal. Luna is our last name. That means money in Spanish, but also deeply symbolic. We are inspired by the idea to go to the moon represents challenge, effort, and imagination.
That mindset of choosing something because it's hard is at the heart of something we do. To us, being at MoonMakers means exploring by doing, and we believe that anyone can invent and create.
Our mission is to create technology and STEM education more accessible and engaged for everyone.
And our vision is simple. We want more young people to feel comfortable exploring, building, and learning through real hands-on experience, wherever they are.
As co-founders, how have you collaborated with renowned international organizations like Sesame Street and Make Community to expand creative technology and maker education for youth?
At MoonMakers, collaboration is key to expanding access to creative technology and maker education. With Sesame Street, we contribute to the Little Adventures program to inspire early interest in programming, robotics, and electronics, especially among girls, promoting curiosity and confidence from a young age. With my community, we helped launch the first ever Maker Camp in Spanish and contribute to the Maker Learning Labs initiative for university students. We also lead interactive sessions at Maker Fairs around the world to engage young makers through hands-on projects and playful learning. We have partnered with organizations like Science Friday to create accessible AI educational resources, and with Arduino, Raspberry Pi, and Microbit Educational Foundation to develop educational content to promote learning by doing. In Mexico, we have collaborated with CONACYT, UNOI, diverse foundations, and institutions have allowed us to train educators and deliver national-scale educational content. A highlight was our work with the Secretary of Education during a program called Recrea Day, where we reach over 12,000 students through engaging hands-on workshops. This partnership allows to bring powerful learning experience.
In today's rapidly evolving tech landscape, in what aspect do you think STEM education is important for the younger generation? How does AI help the young generations starting innovations? And how do you incorporate AI technology into your educational programs to facilitate this process?
In today's tech-driven world, STEM education is essential not just to understand how the things work, but to empower young people to imagine and build what is next. At MoonMakers, we believe that giving students hands-on access to tools like artificial intelligence helps them to go from users to creators. I become a gateway to innovation. When kids train a model or design an interactive project, they can see that Tech isn't magic, it's something they can shape. We integrate AI into our programs through playful access activities like game development, image recognition, and creative storytelling, always focus on experimentation and agency. Because one of the students realized they can teach machines, they realize they can change the world.
How does artificial intelligence inspire your aspirations at a young age? What kind of role do you think AI plays in the process of shaping future leaders?
It doesn't just teach how technology works, it helps us understand how the world works. From algorithms that recommend what we watch to systems that automate a decision, AI makes visible the structure behind our everyday lives. That awareness is powerful, especially for young people. In education, AI becomes a space to explore, test ideas, and solve problems. It develops creativity, critical thinking, and the ability to decide with intention. Most importantly, it helps students move from being passive users of technology to become active creators, a shift that builds leadership by empowering them to question, shape, and improve the system around them.
How does MoonMakers inspire teenagers' interest in electronics through maker projects? For example, coding kits, electronic toolkits. Could you share a memorable student innovation case?
At MoonMakers, we inspire student interest in electronics by connecting technology to a real-life challenge and their own creativity. Using accessible coding kits and hands-on maker projects, we turn abstract concepts into tangible experience. Our workshops are rooted in project-based learning and design thinking, encouraging students to explore, build, and solve problems in collaborative ways. In many of our workshops, we have seen students who have never touched a circuit before become deeply engaged once they realize they can build something themselves. From creating interactive experience to creating projects from scratch, their curiosity grows naturally. This experience often spurs long-term interest and helps students see technology not as something distant, but as something they can understand, shape, and use creatively.
When designing STEM learning kits, how do you balance technical complexity with educational accessibility?
We design our STEM kits to be both technology mindful and accessible to learners for all ages. A great example is our Bolsa Maker, a hands-on kit where you create the first electronic circuit using conductive materials and adhesive LEDs on a tote bag. To enhance the experience, we integrate augmented reality, allowing students to visualize the circuit function in a dynamic way. This approach combines tangible making with the digital interactions, making complex concept approach. By blending our electronic and technology, we create an engaged learning environment that encourages experimentation and creativity. Our goal is to empower students to explore STEM fields confidently, regardless of the priority experience.
Having partnered with open-source hardware platforms like Arduino and Raspberry Pi for years, how do these tools lower the barrier for young makers? Do you plan to develop your own open-source hardware?
Platforms like Arduino and Raspberry Pi play an important role in making technology more accessible, not just because of the hardware, but because of the global communities that support them. The tutorials, shared projects, and forums available around these platforms help young makers learn by doing and feel supported, even when they are just starting out. We have used these tools in some of our workshops and open projects, and we value how they invite to experimentation. At MoonMakers, we design and build our own educational kits, learning tools that combine electronics, storytelling, and creativity. As well, we do create fully documented open-source projects and prototypes with step-by-step guidance so students and educators can build and adapt them easily. After all, our focus is on helping people learn, create, and share. And open tools help us keep that process open too.
You mentioned leveraging emerging technologies like AI and digital fabrication to create inclusive educational opportunities. Could you elaborate on specific projects or plans in this area?
One example is our workshop Shikshulop, held in one state of Mexico, Yucatan. Inspired by the classic egg drop challenge, we integrate digital fabrication, Arduino, sensors, and design thinking to explore physics, coding, and problem solving. Students design their own protective capsules using a 3D printing asteroid with sensor to measure impact and program devices to collect data, all while working with collaboratively to test and iterate their prototypes. Workshops like this make emerging technologies tangible and relevant. We focus on using accessible tools and hands-on challenge to engage students. Our goal is to create inclusive spaces where students can build, experiment, and understand how technology connects to the real world and to their own ideas.
When promoting maker education in regions with limited resources, for example, Mexico, how do you address shortages of electronic components or tools? Do you use localized alternatives? What specific support would you like to receive from electronic component distribution platforms like DigiKey to enhance your innovation journey?
We really appreciate how DigiKey makes it easy to find reliable components and explore new possibilities. It's an amazing resource for both beginners and experiment makers to support innovation even further. And it would be great to see more educational kits and them buttons like wearable sustainability or STEAM. Resources tailored for young makers and education including project-based guides could really help more ideas to take shape and really broader audience.
On a global scale, how do you tackle educational equity to ensure all children access high-quality STEM resources and opportunities for nurturing maker communities?
We approach educational equity by designing learning experiences that are approachable, open source, and adaptable to different contexts, especially where access to technology is limited. Instead of relying on expensive infrastructure, we use accessible materials, open hardware platforms, and digital tools that work both online and offline. We also focus on training educators so they can bring these tools into their communities in sustainable ways by creating content that is culturally relevant, multilingual, and hands-on. We help students around the world connect with education in ways that feel personal and empowering, nurturing makers communities that are diverse, inclusive, and driven by curiosity.
Through workshops and international maker events, how do you foster community empowerment and cross-cultural exchanges? What unexpected lessons have these experiences taught you? How can innovators in engineering and technology collaborate to create a better future?
We believe innovation is stronger when people from different fields work together. Sharing knowledge and building accessible tools can lead to solutions that truly make a difference. Engineers, educators, and creatives each bring unique perspectives, and by collaborating, we can tackle real-world challenges in a more practical and meaningful way.
With 8 years of experience, what 3 skills or mindsets do young engineers and makers need to cultivate to drive social innovation through electronics?
We believe young makers need to cultivate 3 mindsets. First, curiosity. The drive to explore how the things work and imagine how they could work better. Second, collaboration. Because innovation grows stronger when we share, co-create, and connect with others. And 3, a creativity, a hands-on approach to problem solving, being able to experiment, prototype, and iterate, even when the outcome is imperfect. This value reflects on the heart of the maker moment, with purpose, learning by doing, and using technology not just from the sake of it, but to create a mindful change in the world.
DigiKey